I don't know. Is it recording twice? That'd be super weird. Whatever. All right, chapter 4, section 1. So, graphing quadratic functions. So, first, what is a quadratic function? They are having a term with a variable to the second power. So, we have something that's like an x squared function. So, something with a squared. A quadratic function must have a quadratic term. A quadratic term has that x to the second power. It may or may not have a linear term and a constant term. So have it drawn out for you. The linear term is literally the one with just a x to the first power, and then a constant term is just a number. But in order for it to be a quadratic, it must have an x squared term. If the x squared term was not there, it would just be linear, because it would just be y equals mx plus b. But to be quadratic, it has to have that x squared. So this is a quick reference summary. Like, how do you graph, etc., etc. We're going to go, like, this I put on the front because it's the front of your notes. It's very easily accessible, but we're going to be going through every single one of these details. All right, so first, standard form of a quadratic equation. F of x equals ax squared plus bx plus c, where a is not equal to 0. So you have to have that x squared function. All right, so let's graph x squared using a table of values. The graph of a quadratic is called a parabola. So this is not the first time we saw x squared. Remember in chapter 2 when we talked about transformations? We did that whole thing on our calculator where we graphed different functions and we saw them move and translate. We did x squared. Well, now we are going to work with x squared. We already did lines and we did absolute value, the v's. Now we're going to do the u's, which are the parabolas. So what we're going to do is let's plug in our x value into the equation. So I'm just plugging in. Come on. Select. Oh my God, it's so slow. Why is it so slow? All right. So I'm going to plug in my x value and square it. So this is just -1 times -1. What is -1 times -1? 1. Okay, what is 0 squared? 0. How about 1 squared?
Oh, it's just squared.
1. 2 squared. 4. So a parabola, we're just doing the basic x squared function. What do you notice about the numbers?
You don't get negative.
They're not negative because we're squaring. And also, hoping this pops up. Yeah. Look how those match up. Interesting. So we're going to focus more on those later. I just want you to see the pattern. All right. So my first point, -2, 4. Then I have -1, 1, 0, 0, 1, 1, and 2, 4. All I'm doing is I'm plotting my x, y coordinates, right? We found y based on x. We plugged x into the equation, found what y is. Do we remember going over this in Algebra 1b or Algebra 1? Mm-hmm. Yes. Hopefully, because this is the exact same notes. I just stole it from Algebra 1 right here. I just want you to make sure we're connected. Okay, so let's connect the lines. Are they going to be straight? No, it's going to be a little curved. It's going to be curved in a U shape. Curved in a U shape. Curved in a U shape. Awesome. So this is our first parabola for the year. First parabola. And I'm a perfectionist, so I want it to look nice. Okay. This is our first parabola. Notice how does this half of the graph compare to the other half? How does that half compare to this half? Exactly. It's a reflection. So there's this thing called the axis of symmetry. Literally just a vertical line. Whatever's on the left side is reflected across to the right side. It's an axis of symmetry. So we're going to go over that more again. I just want you to see the pattern, have an idea of what's going on before we actually do it.
Wait, do we need to color it?
No, you don't. This is all I want you to do is just graph it. This is, so right now, since we're really starting the chapter, I'm trying to get an idea of what is your previous knowledge? How much do you remember? Like, do you know what we're doing, or do I need to slow down? It gives me a better idea how I can, like, meet you where you are. Like, if you are totally lost, cool. I made the notes, so you know, I'll act like you never saw it. But if you guys are, like, grooving with it, it gives me a better idea how I can, like, make this chapter more useful.
I'm really like, I'm kind of having trouble with this.
Okay, but you understood how we graph this?
Yeah.
Awesome.
I understood how to graph it. I just the like whole like plugging in stuff is kind of like all the equations.
So I'm just plugging in x to find what y would be. So that's what we're going to do now. We're going to use this table of values to graph the function.
We'll pick any ones we want.
So ideally, the easiest ones. We pick the easiest ones, which are like, right, so I'm going to be choosing -2, -1, 0, 1, and 2 to plug in. Those are the easiest to find. So I plug it in for x. So I have -2 squared plus 3. But we already did -2 squared, remember? So -2 squared is 4, plus 3 is 7. Yes.
Bathroom.
Yes.
Thank you.
Your bathroom. Right.
Phone is here.
Okay. All right, so see if you can plug in the rest of the values and graph it. And if you're done with A, try out B. So see if you can plug them in yourself, just like how we did for example 1. I want you to do both graphs, the top one and the bottom one. It's our first full week. It's like our first full week in a long time with all the Jewish holidays.
No, it's
So, what I want you to do, fill out this table, plot your points, make the parabola. After you're done with A, do B. I want you to really try it. Okay, so I'm gonna fill this out.
What if you did numbers like 1, 2, 3, 4, 5?
You would find numbers that'll go off the graph.
Oh,
Try it yourself.
no, I'm dead.
Wait, does it not have to go through the direction?
Nope. So this is what your graph should look like. But wait, this makes sense. Because remember, we went over transformations. And if we have our function plus 3, what does the plus 3 do? Shifts it up by 3. So look at this example 1a compared to our original graph. All I did is I shifted my whole parabola, the whole U-shape, up by 3 units. Amazing. That's all it did. Just every single one is up by 3 units. See, you already knew how to do this. Yes?
Can you pick the number?
Sure, you could plug in any numbers you want. It's just the most useful. Like if I plugged in 5, let's see what would happen. So I have 5 squared plus 3. So that's 25 plus 3. That's 28. That's off our graph. Yeah. And remember, the square is you're literally taking the number multiplied by itself. You're not multiplying by 2. You have to take 5 times 5. If I plugged in 3, right? If I plugged in 3, you'd have 3 squared plus 3. So that's 9 plus 3 is 12. That's also off our graph. So you guys already know how to recognize a horizontal shift. You may not realize it yet. And we're going to that's what 4.7 is literally transformations. We've already done it. But guess what? We're going to go over it again. Questions over this one? Okay, so I'm going to go to the next one. All right, so I'm going to pick a couple easy numbers for us. Ideally, I picked the easiest ones to compute. We'll see what the graph should look like. So I have negative of -2 squared minus 1. So that's -4 minus 1. Wait, why is it -4? I thought a negative times a negative is a positive.
There's a negative on the outside.
There's a negative on the outside. Exactly. So notice the before when I was doing negative 2 squared, I was doing negative 2 times negative 2. I'm still doing that, right? So this portion right here goes to positive 4, but there's a negative on the outside. So wait, what does the negative on the front, what does it do? It flips it upside down. If you don't see that, don't worry. It's fine. Right now, all we're doing is just plugging in negative 4 minus 1 is negative 5. So negative 1 minus 1 is negative 2. What? This portion for graphing would be on the no calculator section. Because if this was on the calculator section, people would plug it in and just copy from the calculator. And that's not what I'm testing you on.
Is there like a way that you could, because like I suck at like the negatives like outside of like, I always just mess up, and I know how to do it. I always just like mess up because I get anxious sometimes. But like,
so we have we have multiple days of like practice. So literally, if you're not good at it now, like we're just gonna be practicing in class, we're gonna be practicing on our homework, etc. Yeah. Like just give it a shot. Like right now, there's no way if I give you the no calculator portion that you would do it. No way. But by going through in class and like showing you how I would do it, right? Thinking out loud, doing an example, and then you try it that way on your homework. It's very important you practice the same way we do it in class on your homework. Don't just plug it in your calculator. Then why? Why would I even assign homework if that's useless? All right, 0 minus 1, so it's negative 1. Negative 1 squared minus 1. What are you noticing about the numbers? They're all negative. What else? Do we see a pattern?
The top two are the same as the bottom two. Like negative 5, negative 2, and negative 2, negative.
Right, you see there's this like symmetry on my parabola.
Isn't it like always the same?
Yeah. It's always going to be a nice U shape. The right half is always going to be equal to left half. All right, so I have 0, comma, negative 1. Negative 1, comma, negative 2. Negative 2, comma, negative 5. 1, comma, negative 2. And 2, comma, negative 5. I connect them to have a nice U shape, and connecting it, we see, oh, it's facing down. So if there's a negative in front of the x squared, what that does is it flips it into a frowny face. Remember, if you're negative, you're probably very sad, right? You're sad. The U shape is going down, right? If you're negative, you're a very sad person. But if you're positive, right? If it's positive in front, you're such a happy person. It's going up, facing up. No, okay, that's fine. Okay. Sometimes I say things. That's why I erased it, because it's scary. Sometimes I say things, if it doesn't land, like if it doesn't resonate with you, cool. But like I'm trying to give it to you as many ways as possible. All right, so we've tried these problems. Let's try the next two. Just looking at C, is this going to be facing up or down? And how do we know? Up. How do you know? Because it's positive, right? In front of x squared is positive. Beautiful. This is great. You guys are doing great. All right, so let's plug in. I'm just going to keep my same numbers, and let's see what happens. So, this one's a little more tricky. So I have negative 2 squared plus 2 times negative 2 plus 1. Okay. So I have 4 minus 4 plus 1. That's just 1. Negative 1 squared plus 2 times negative 1 plus 1. So it's 1 minus 2 plus 1. So it's 0. If I plug in 0, plug in 1. So I want you to like try plugging these in yourself. See what you get. I'm trying not to go too fast. Ideally, you try to plug these in yourself. So you make a little chart for yourself, right? That's the easiest way to graph it. So this is a little weird because normally like the top and bottom match, the middle two match. But I see, okay, so I have 0 and then 1 and 1.
Wait,
So it seems like it's shifted horizontally a little bit. It's not just gonna go, it's not just like on the y-axis, it's gonna be shifted over a little bit, but it's still gonna be a U-shape. Okay, so -2, 1, -2, 1, -1, 0, 0, 1, 1, comma 4, 2, comma 9. So I see the U shape here. What do you think about, it should be symmetric, right? So wait, what should the y value of -3 be?
oh, so are we supposed to figure it out?
What do you think the y value of -3 would be without even plugging it in?
4.
4. Let's make sure we're right. -3 squared plus 2 times -3 plus 1. So this is 9 minus 6 plus 1. It's 4. So you knew what it would be without even like plugging in. So how do we know that? Right? How do we know that? What? Well, I probably should have added a box, but for it below, like this. I'd give you like more boxes than you need.
Wait, so is that
Yeah.
like the point of this problem? Are we supposed to find the missing point?
Well, what I want you to notice, well, let me come up here for a sec. So you notice right here, I have a point 1 space to the right and 1 space to the left. It's symmetric. Here, 2 to the left, 2 to the right. So looking at symmetry down here, wait, if I have a point that's 2 to the right, I should have a point that's 2 to the left. Up here, I have a point that's 3 to the right, so I should have a point that is 3 to the left as well. And I guarantee if we plug in -4, if I plug in -4, the y value is going to be 9.
You're just moving the center axis over.
Yep. -4 squared plus 2 times -4 plus 1. So that's 16 minus 8 plus 1. 16 minus 7 is also 9. So technically, I probably should have put it up here so you could see like how these two line up. Like there is symmetry as you go away from the vertex. The vertex is the bottom of the U. Remember how we had vertex with our absolute value? The vertex is where the two parts of the V meet. The vertex for a parabola is the bottom of the U. And the left half of the U shape is the same symmetric as the left half of the U shape. There is symmetry.
Yes.
Okay. So we're going to skip D. It's just more plugging in. So each parabola has a maximum, highest point, and a minimum, the lowest point on the graph. So a maximum is like you have a hill. You have a point where it's at the highest. A minimum is a valley. You're at the very, very bottom. Okay, please don't do that. You're going to smack yourself in the face. I've asked you. That doesn't mean do it more. Okay. All right, the min or max is called the vertex. It's at the either bottom of the U or it's at the top of the frowny face, right? It's literally the point at the top of the hill or at the bottom of your valley. Yes. Yes. So how do you find the vertex? The vertex is the, to find the x coordinate, you do -b over 2a. Just a second. Just a second. forgot to take attendance. Talia's absent. Lauren's absent. Okay, cool. All right, so each parabola has a maximum or a minimum. The x value of your vertex, you find it by saying negative b over 2a. And to find the y coordinate, you take whatever value you found, right? So you plug whatever number negative b over 2a is, you plug it back in to original equation and you'll find the y. And the line that divides a parabola into two halves, right, that line is called the axis of symmetry. So up here, I was introducing you to the axis of symmetry. Notice the left half is the same as the right half. This section over here is symmetric to this section. It's kind of like you just folded it over. It's the same U. Okay, so write the equation of the axis of symmetry. Find the coordinates of the vertex of the graph of each function. Identify the vertex as a max or min and graph the function. So there's a lot for us to do on this problem. So much. All right, so the first thing we want to do is write the equation for the axis of the line of symmetry. Eli, how do I find the axis of symmetry again?
It should be the line that divides the graph.
Yeah, so how would I find it? Do we know the axis symmetry?
Oh, it's x equals negative b over 2.
Exactly, x equals negative b over 2a. Why is this not going? X equals negative b over 2a. So wait, what is this b and this a? Where is this even coming from? Do we know what these letters are? So the equation for parabola quadratic is ax squared plus bx plus c. So the b is the number in front of our x, and a is the number in front of x squared. Why is this so slow? Ah. Okay, here, this is my b. My b is 4. What is my a? What is the coefficient in front of x squared? 1. So that's going to be my a. So we can go ahead and we can plug in. B is 4. So this is going to be negative 4 over 2 times 1. What's 2 times 1? 2. What's negative 4 over 2? Negative 2. So the axis symmetry is x equals negative 2. This is the equation for the axis symmetry. Meaning, if I draw a vertical line at x equals negative 2, the part of the parabola that's on the left side is going to be symmetric to the part that's on the right side.
How do you get the b and a?
All right, so we looked at the equation for the quadratic. The number and the coefficient in front of x squared is a. The coefficient in front of just the plain x is b. So you have x squared and you have x. The x with the
Without the square.
yes, without the square.
Is
So-
there b?
Yep, this is the b, and then since there's no number in front of x squared, we know the coefficient's 1. Because the equation is a x squared, so a is the coefficient in front of x squared, plus bx, b is the coefficient in front of x, plus c, and c is just the number that's the constant at the end. Okay, so I have my axis of symmetry. The next thing we must do is find the vertex. How do I find the vertex now that I know the axis symmetry? So, to find vertex at the top, it says x coordinate is negative b over 2a. So we already have the x coordinate of my vertex. It's negative 2. So the first thing we did was the axis of symmetry. Now we're going through and finding the vertex. To find the y value of my vertex, I have to take the x value and plug it back into my equation. So I take negative 2, plug it back into the equation at the top. So let's see, up here, I'm going to have 0, negative 1, negative 2, negative 3, and negative 4 be the numbers I plug in. And as we go on, like, you will get a better intuition for which numbers to choose. So I give you 5 boxes, and the vertex is always going to be that middle box because that's where the axis of symmetry is, and I know whatever's on the left side will be symmetric to whatever's on the right side. So my x value, which is the axis of symmetry, is always going to be this middle portion. It's always going to be the middle number. And then I pick 2 numbers to the left and 2 numbers to the right of it. Because the axis of symmetry, it's like, oh, it's the very bottom of the U, so whatever's on the one side will be symmetric to the right, to the other side. So I want my axis of symmetry to be this middle number. Okay, so let's go ahead and let's plug in and let's find what the vertex would be. So I have negative 2 squared plus 4 times negative 2 minus 5. So negative 2 squared is 4. 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. Cool. So my vertex is at negative 2 comma negative 9. Okay, so remember, the directions say, write the equation of the axis of symmetry, check. Find the coordinates of the vertex of the graph of each function, check, we found the vertex. Then, identify the vertex as a min or max. I mean, it's kind of hard to tell without graphing. Do we have an idea of what it should be? Okay, so first, is this facing up or down?
Up.
Up, because it's positive. So it's facing up. So if you look at your U shape, it's like a smile, so it goes down to a min. Okay, so great. You guys are able to recognize that's a minimum without even graphing it. But we're going to graph it anyway. Okay. So we're going to go through and we're going to find all of my other values. Then I will graph the function, and then we can go back and make sure our intuition was correct. So these little numbers I'm circling is kind of like the order of how we're going through the problem. First we found the vertex. First we found the axis of symmetry. Go through, find the vertex. We're going to go through, find the other numbers, graph those numbers, make sure it's actually going to be a minimum. All right, let's go and let's plug in. 0 squared plus 0 minus 5 is a negative 5. So I'll give you about 15 seconds. Try to find these numbers, not just copy them down. Trick play. You only have to figure out 0 and negative 1. Why did I not show work for negative 3 and negative 4?
It's the same.
Because they're the same. We found the axis of symmetry. So I know whatever the y value is for the number 1 to the left is going to be the same y value as the x value 1 to my right. How do I describe this? Oops. So I know since this is like the axis of symmetry, I know these two will be the same. And I know these two will be the same. That's what symmetry means. It means it's symmetric. What's on the left side is going to be the same as on the right. Symmetric. What's another way to describe what I'm trying to say? Can someone like rephrase in different words?
Fold it.
So it's kind of like you fold it over. It's beautiful. Exactly. So it's like you fold it. So if I would draw one part of my parabola, imagine it's paint and I fold it at the line of symmetry, it's going to make the same shape on the other side. Beautiful, beautiful. Okay, so let's graph it. All right, so I have negative 2 comma negative 9. That's my vertex. And then negative 1 comma 8 and negative 3 comma negative 8. 0 comma negative 5 and negative 4 comma negative 5. So we're right? It's opening upwards, and we see it goes down to a minimum, and then it goes back up again. Right? So it's going down to the lowest point and then up, which means it had a minimum. So we know we're right. It goes to a minimum. So while I give you time to like finish drawing this, graphing, think about the domain. What would the domain of this be? Because keep in mind, I didn't just put discrete points. I didn't just put the points. We went through and we connected them. So it's going to be it's a continuous function. What's the domain? The x values. Are there any x values where if I had plugged them in to the whole equation, x squared plus 4x minus 5, is there any x value where if I plug it in, it would not give me a y? If you graph this and you keep zooming out, it's just going to keep showing you this U shape. No matter how much you zoom out on your calculator, it always will show you this U shape. So that means the domain is
All real numbers.
all real numbers. 3 words. All real numbers.
You just read that far.
Exactly. So it's like you're drawing an R, except you have a second line, and then you do the R. All real numbers. So that's the 6th thing we did, was find the domain. And lastly, the range. Ooh. Where on our parabola is y equal to negative 10? Nowhere, right? Because the lowest it goes is negative 9. All the y values are going to be, it's either negative 9 or greater.
Sure, inequality.
So we're going to write an inequality. So y is going to be greater than or equal to negative 9. Because I have a minimum, all of my y values have to be bigger.
This is a lot of steps.
Yeah, I know. It is. It's a lot. But you guys are doing great. I'll show you how to find min and max on your calculator. We got lots of practice. It is a lot of steps. That's because I'm like making like every single part a step. Nice and slow. All right, ready? Not trick question. What if my graph looked like this instead? What would the range be? So I know I have a max. What would the range be?
Y is greater than, less than 9.
Then some number. I don't know what it would be, but some number. That's the difference. So when you have a minimum, the y is always going to be greater than or equal to. When you have a maximum, y is always less than or equal to. So it's always smaller than the max. Okay. Pretty solid. It's already like 5 pages of notes. I'm trying to give you like plenty of space to write. Shall we try the next one?
I have a quick question.
Yep.
What time is class end?
45, I believe. Yep. Still got 12 minutes.
I know, I just want to see the puppies.
I know, I'm so excited. It sucks so bad last year for the people who were like just standing there watching. Just like,
Aw.
no, it was like torture. Really.
All right, let's try this one. So the first thing we want to do is find the axis of symmetry. First thing we want to do is find axis symmetry. How do I find the axis symmetry, Dylan Benson? Got him.
X equals negative b over 2.
X equals negative b over 2a. Okay, so I need to find what my a and b are. So I come up here, just going to scroll up. So my a
Negative 1.
is negative 1. And my b is 4. Because it's ax squared plus bx plus c. So the b is the coefficient in front of x. The a is the coefficient in front of x squared. Here a is negative 1. Okay. So let's scroll down. So how do we find axis symmetry? The top of the previous page, it says negative b over 2a. So I'm going to plug in. Come on. So I have negative 4 over 2 times negative 1. So negative 4 over negative 2 is just 2. So my axis symmetry is x equals 2. This is the x value that is the exact vertex. It's the bottom or the top of our like U shape. That is the location where if I look to the left and the right, we're making our butterfly wings. That is the exact center. So when I come to my 5 boxes, I'll always give you 5 boxes. The one in the exact middle, I'm going to put as 2.
0, 1, 2, 3, 4.
So I put 0, 1, 2, 3, 4. Your axis symmetry, I always put as the middle one. Because then it makes it easy. Because then I can just plug in the number that's 1 to the left and 1 to the right. Okay. Step 1, axis symmetry. Awesome, done, check. Now we have to find the vertex. So I found the x value, but what's the actual y value of my parabola? So I have to plug into the equation.
I'm so confused with the axis.
I think you were in the bathroom when we talked about it.
Yeah, there's you put some of it. I'm just.
Okay, so yeah, Ashton, you can explain to her.
Is it 10?
So let's plug it in. All right, so negative 2 squared plus 4 times 2 plus 6. So it's negative 4 plus 8 plus 6, 14 minus 4 is 10. Yeah, 10. Perfect. So we found vertex second. The third thing we're going to do, find the other values, and then we'll graph them. So we find, exactly. So just by looking at the equation, you see it's a negative in front of x squared. You know, be facing down, it's a sad face, and it's like a hill, a sad face. Goes up to a max. Okay. So it's 6, and then let's see, find the other one. Negative 1 plus 4 plus 6, that's 9. And then just use the, you know it's going to be symmetric. All right. So go ahead and plot them. Our lovely Elizabeth has already said it's going to be a maximum. And if you, after you graph it, you'll see as well, it will be a max because the number, the coefficient in front of our x squared is negative. And if you are negative, you're frowning. So it's a frowny face. And if you think about a frowny face, it kind of looks like a hill. You go up to the top and then like that is the maximum. It's the highest you go. So it's a max. Let's go ahead and plot it. 0,6, 1,9, 2,10, 3,9, 4,6. Awesome. So if you didn't automatically see, like, it is a max. That's why I put this as like, oh, this is the order we're going through. That way if you like look later on the notes or people who are going to watch the screencast, they see the order that we completed these steps. First, we found axis symmetry, right? So using the axis of symmetry, you notice it goes right there. Then, now that we know the vertex, wait, this 10 is the maximum amount, right? So the range is going to be y is less than or equal to 10. It's literally the value of our vertex. And the domain is still all real numbers. It doesn't matter what you plug into a parabola, it will always give you, parabolas always be all real numbers. Okay. Yeah.
Will it ever be greater than like 10 or
So if this was, if we didn't have the negative sign in front, it would totally change the problem. The negative in front of x squared, it would totally change the
So
problem.
would it be greater than or equal to? Would it just be greater than?
Right, that was our last problem. You saw how this number goes right here. This number matches that one.
No,
So your x symmetry is your x of your vertex.
But the equal to, will that always be?
The or equal to, yeah.
Okay.
For a parabola.
The line underneath the.
The or equal to, yeah. For a parabola. Okay, so we have our calculators. This is the next part.
Is the domain always all real number?
Did I mean to put this here? What? Yeah, for a parabola, it always will be all real numbers. So let's go through and let's see how we can find a min and max on our calculator. So open up your calculator, click on New Document, and add graph. Do not save previous document.
I don't have my calculator.
It's math class.
I know.
I'm still on Tessa's head.
I meant to take you guys off today. Is anyone taking the ACT this weekend?
Oh, I still have this on my calculator.
Yeah, I noticed I'm missing one.
There you go.
I need it back. Now you gotta put it away. I'm not taking it.
Actual one just became.
Yeah. Okay, ready? So I go to, put it in there. Go to my calculator. I say add graphs. So if this is not popped up for you, right? If there's no line tangent, you have to push tab. Let's go ahead and let's enter in the equation. It says x squared plus 4x plus 6. So x, and notice the little squared key. Oops. My bad, hold on. X squared plus 4x plus 6. Right? That was the graph we just did? Well, no, it was actually a negative. My bad. It's alright. Let's just enter this one in anyway. Because this is what I put on your notes. Okay. So I have x squared plus 4x plus 6. And now, if I want to find, is this going to have a max or min? Min. Okay. Let's find out what the value is. So you push menu. Analyze graph. Minimum. Exactly. This is exactly what you did in Algebra 1B. Ready? You go left of it, and it will find the minimum for you.
And that's the vertex, right?
It's the vertex.
Why is mine in rel 1?
Oh, it's in yellow?
No, it's in log 1.
Rel. Okay, so you have to push menu, graph, entry, edit entry, and then you can push function.
On the test, will there be like one without and some with?
So just like so if I put a negative here, it will like, oops, did it not tell me? So on the test you took yesterday, there was a question that was like, find the intersection. And it was like this hard, nasty one you couldn't actually graph by hand. Yeah, I'll give you a parabola. Okay, you know what? Let me show you something that would do. So something like negative, make it positive. Okay, but like 1.24 x squared plus 4.52 plus 6.818. This is not something you graph by hand. But a question I would give you is like, what does it have a min or max? And find the vertex. Well, how do you find the vertex? Oh, menu, analyze graph, minimum, left bound, right bound, boom, it pops up. Easy question for you to get. It's literally using your calculator.
It's fun learning all the buttons.
Yeah.
Wait, so how would you do it? Analyze graph.
Let's do it together.
Minimum and maximum.
Oh, yeah, minimum.
Menu, analyze graph. And I'm going to click minimum.
Oh, yeah. Okay.
So it says lower bound question mark. So you have to go to the left of your minimum. Click upper bound question mark, go to the right. And then it pops up your
How
minimum.
do you do the zoom in thing?
If you go menu, window zoom, you can go standard if it's all crazy. Just push standard and it'll go back to where. Okay, so this is a great place to stop. We'll definitely finish this lesson next time. Have a good start to 4.7. Okay. You could like try. I mean, we've done most of it. Have a good rest of your weekend. Go early to the doggies, 2 minutes early. Yeah, 2 minutes early doggy time. Just a moment. Why is this not popping up?